Hey everyone, so here's a video just giving a little bit more of an explanation as to why the force gravity on the hanging mass is the only force that's causing the system to accelerate, and it's the only force in our net force, also known as what about the tension force? Because I was getting some questions before about why we only think about the force gravity as the net force and not the force gravity minus the tension force, which is what we would normally look at. So when we think about our system, remember that our system is everything that's attached to the string. So in this picture, it's block 1 and block 2 are our system. And so the tension forces, I've drawn the force diagrams already, normal force and force gravity 1, the force tension on block 1, and then in the second one, I have the force tension going up for the hanging block, and then force gravity 2 going down, with force gravity 2, or the force gravity on the hanging block being bigger than the force tension, because we know it's going to speed up as it falls down, so the forces should be unbalanced. And so when we think about the tension forces are considered internal to the system. And we can think about that by kind of drawing a dotted circle around our system, because our system is the two blocks. And so if we look at our circle, or what we drew around our system, the tension forces are inside of that. Whereas the force gravities are being exerted by something outside of the system. And so I can show you that mathematically as well. And I think sometimes showing it mathematically gives a little bit of a better vision or ideas to what's going on. So I'm going to look at each of my individual blocks. So for block number 1, since it's going to move to the right, I'm going to make right positive. Okay. And then for my net force equation for the horizontal direction, I'm going to write force tension equals M1 times A, the mass of block 1 times A, because we're looking again with Newton's second law, net force equals MA for all of these net force equations. So now for block 2, since the block is falling down and speeding up while it's moving down, I'm going to make down my positive direction, because that's the nice thing about physics is you can make whatever direction you want to be positive. And so if I write my net force equation, since down is positive, I'll do FG2 minus force tension equals M2A. And so now, since my acceleration is also down, I can leave my acceleration positive. And so the big thing that we need to remember is, because these are attached to the same string and the string is moving over the pulley, these two force tensions are going to be equal. And since the two blocks are moving as one object, the acceleration of block 1 and the acceleration of block 2 will be equal as well. So we can use that to our advantage when we're looking at these two net force equations with two unknowns. So what I'm going to do is I'm going to take this equation, force tension equals M1A, and I'm actually going to plug it in over here and substitute. And I'll get that FG2 minus M1A equals M2A. Then I can move the quantity of M1A over and get FG2 equals M2A plus M1A. And then I can, since these two accelerations are the same, I can pull out the like term and get that FG2 equals the sum of M1 plus M2 times A. And now if we look at this new equation that we have, this is our net force equals MA, where our M1 plus M2 is the system mass, and this force gravity 2, which is the force gravity on the hanging mass, is what the net force of the net force that's being exerted on the system. So that's a mathematical way of showing that the tension forces are internal to the system. So the only thing, when we actually look at it mathematically, the only thing that we end up with is force gravity 2, or the force gravity of the hanging mass, causing the whole system, which is M1 plus M2, to accelerate. So hopefully that helps a little bit in terms of why the force tension doesn't contribute to the net force. And I'm going to make another video showing you guys what would happen if there was a table that did have friction. So hope you enjoyed that, and see you in the next video.